Hello, welcome to the video. In this lesson, we're going to be looking at section 5.5, where we're going to be proving triangles congruence by SSS or side, side, side. Okay, so in this um, section, we are going to be asked to prove triangles are congruent by side, side, side. So in order to do that, we have to, we either have to know that corresponding sides are congruent for each of the triangles, or be able to use properties to determine that those corresponding sides are in fact congruent. So basically, um, side, side, side congruency basically states that as long as the three sides of one triangle are congruent to the three sides of the second triangle, then the two triangles are congruent. So to start off with, we're going to look at a proof of this diagram here. They're telling you that KL is congruent to NL. They're also telling you that KM is congruent to NM. They want you to prove that triangle KLM is congruent to triangle NLM. So right now, the only um, one that they don't show us as like a hash mark is LM is congruent to LM. Well, we know that that's part of the reflexive property. So when we write out this proof, we can say, all right, we got our statements, we got our reasons. Our first one's going to be KL is congruent to NL. And they also say that KM is congruent to NM. That was given to us. The second part now is we can say that LM is congruent to LM because it's part of both triangles due to the reflexive property. And I'll just make a little hash marks there. So we have all the corresponding sides showing that they are congruent. So now I can say that triangle KLM is congruent to triangle NLM because of side, side, side. Here, they're asking us to decide whether the congruent statement is true, and they're asking you to explain your reasoning. So what we have to do first is look at the congruency statement. So for number one, that is our congruency statement. We want to make sure that how they wrote it in the statement is consistent with what is true with the diagram. So first off, I'm going to look at, all right, so first and second is DF. So I want to say, is DF going to be congruent to HJ? So 2 and 2, all right, that checks off. Now let's take a look at 2 and 3. So FG, I want to see if that is going to be congruent to JK. 3 3 marks, checks off. And then 1 and 3, so DG is congruent to HK, 1 and 1, checks off. So the explanation in this one, this is true because the corresponding sides um, match up. So if we looked at the second one, we got first and second AC. AC needs to be congruent with CA, which is also AC because they're reflexive. So that checks off because it's a reflexive property. They're both 9. Next is CB. I want to see if that is congruent to AD. So CB is 7. AD is also 7. So that checks off. Finally, we got AB, first and third. And we got CD, which is, so AB is 3, CD is 4. That's not true. So this one is false. All right, that is a false statement because one of them didn't work out. One of the corresponding sides were not the same. Looking at number 3, first and second, I got QP. I want to see if that's congruent to RS. So QP is 2, RS is 2. That checks off. PT is second and third. Is that congruent to ST? So PT is 3, ST is 3. It checks off. Finally, first and third, QT, is that congruent to RT? So 1 and 1, it checks off. Yep, this is true due to the fact that the corresponding sides do match up and they are congruent. Here, they're asking us to explain why the bench with the diagonal supports is stable while the one without supports can collapse. So the solution to this is this. It says the bench with the diagonal supports forms triangles with fixed side lengths. By the side congruence theorem, these triangles cannot change shape, so the bench is stable. The bench without diagonal supports, this one, is not stable because there are many possible quadrilaterals with the given side length. So depending on how it be moved, it could be a rectangle, could be a parallelogram, some stuff like that. So when you are looking at diagonal supports, not only do they have to be diagonal supports, but they also have to form two triangles. So keeping that in mind, looking at uh, these 3 diagrams, of the 3 diagrams, there's only one that's stable, and it is number 5. Number 5 is stable. Numbers 4 and 6 are not stable. Number 4 is not stable because there is no diagonal support. Number 6 is not stable because, yes, it does have a diagonal support, but it does not form 2 triangles. It has 1 triangle and 1 quadrilateral. In previous sections in this chapter, we talked about um, side angle side. And the only way that side angle side worked is if you had a congruent angle in between 2 congruent sides. The only um, exception to that is the theorem called hypotenuse leg. All right, hypotenuse leg states that if you have a known side that is the 90-degree angle, and you have 2 uh, congruent sides, one of them being the hypotenuse and the other one being another leg, you can use this theorem to prove that 2 triangles are congruent. And in this particular instance, it's 2 right triangles that are congruent. Okay, so with that being said, here they're telling you that um, they're giving us that WY is congruent to XZ, that WZ is perpendicular to ZY, and XY is perpendicular to ZY. So let's see here. Looks like here, actually what I'm going to do is this. I'm going to rewrite this as 2 separate triangles. So I got W, Y, and then Z, and then this one here is X, Y, and then Z. So they said that WY is congruent to XZ, which is right there. And they're telling you that WZ is perpendicular to ZY, which means that's right angle. And XY is perpendicular to ZY. So that's what we have so far. Writing this as a proof, statement and reason. First off, write what's given, WY, congruent to XZ, and then they said that WZ is perpendicular to ZY, and XY is perpendicular to ZY. So all of that stuff was given to us. So to start with, we can make the conclusion because of the perpendicular lines. I can say that angle Z and angle Y are right angles due to the definition of perpendicular lines. And if they are right angle, we can then conclude that these two triangles are in fact right triangles. So I can say that triangle WYZ and triangle XZY are in fact right triangles due to the definition of right triangles. Because we have one 90-degree angle. So we have right now in our triangle, so the one we drew up in red, I have a set of congruent sides, and technically I have a set of congruent angles because they're both 90 degrees. Next, I know that they both share ZY or YZ, so I can now say for this fifth point or fifth statement, I can say that ZY is congruent to ZY due to the reflexive property. And so since I have a hypotenuse that is congruent, I have another congruent leg, and I know that it's a 90-degree angle, I can now conclude that triangle WYZ is congruent to triangle XZY due to using hypotenuse leg theorem as our reason. In this one here, it says redraw triangle ABC and triangle DCB side by side with corresponding parts in the same position. It says use the information to prove that triangle ABC is congruent to triangle DCB. So what I'm going to do is, so I'll kind of try to draw it a little bit like BC or DCB. So I have, so it would be like C is right here. Here's A, and that's B, and this was 90 degrees, so that's what we have here. And they said that AC and BD were the same, so here we go. All right, so I just kind of drew them in the same position. Here's how we can prove that these in fact are congruent triangles. So my statement and my reason. So the first thing is they're telling you that they give you AC is congruent to um, BD. And they also say that what angle C and angle B are right angles. So that was given to us. So the second thing that we can look at is they both share a line segment BC. So I can say that BC is going to be congruent to BC because of the reflexive property. And in this particular instance, AC and BD are the hypotenuse. I have I have a leg that is congruent. I know that it's 90 degrees. So in this particular instance, I have all the information I need to say that ABC is congruent to DCB because of hypotenuse leg. And that is being able to prove triangles congruence by side, side, side. Hope this helps. Until next time.